Hello guys, how are you? Morning. तो आज हम मैंगो बॉट को थोड़ा और चेंज करेंगे. Is everything good? Let me check. Hello, 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 hello. Yeah, all good, all good. Um, I'm seeing the screen. Right? Okay, so let me go to Obsidian. Yeah. So what basically is this mango bot? Yesterday I created a like fresh starting video to explain this, but let's continue this one. Uh, Good joining also if you want in the chat. Okay. So what is the mango bot, right? Helps you to take take actions in your computer with your command and its memory. So it's kind of a layer. It's a layer over your brain, right? So like very simple thing can be when you tell it to do something, right? But that can easily be extended to uh, you know it understanding what you really want, depending on like what your patterns of working, or let's say uh, what you say. That is the so basically, okay, let me type it down. So key inputs, key inputs for it to take actions. So the very primary thing is, let's say, your prompt, right? Your prompt. So this can be either in the form of text, in the form of text, or your audio, which is itself text. Uh, and let's, okay, that's it. Secondly, this can be, you know, uh, yeah. The second thing is according to your memory patterns. So let's say how to understand this. Okay, is this team good? Yeah. So, so memory patterns, right? So what are memory patterns? So for example, every day, let's say when you open your computer, right? So what all things you need? So some, let's say I open Obsidian for notes, right? Every morning. So I don't have to like use uh, like my brain to actually open Obsidian. So it should actually recommend me, and if I give it some gesture, it should actually like open the notes and like create a new note for the day, and all these tasks, right? So for now, I have to like do it, but you know. like this is a very simple task, but sometimes let's say it's a very complicated task, or let's say it's a task which requires a long sequence of actions which simple human being cannot do, or let's say it's very tough for you to actually do it, right? So, or like tedious. So the main thing is it is tedious. So tedious or tough things which can be guessed from memory, right? So memory patterns from past actions, right? And thirdly is prediction. So this is one another thing. So prediction, what is prediction? So it should know like what generally humans do while doing something. So for example, when you want to let's say buy a pizza from somewhere, right? So example, right? Yeah, example, buying pizza requires you to actually navigate to the pizza site and let's say so like this navigation though is simple, but like let's say when you're navigating, you're scrolling down, you're talking something. So these are very like key things which using which what you want can be guessed, right? So all these are prompts and keys, right? So it should predict like, basically what your prompt is. So again, the third thing is predicting one and two. So, and that the third, the model can be trained on general people data, and it can be aligned to what human actually needs, right? So, so third is prediction. So there are three main inputs to this bot, uh, which can the basic inputs for deciding the task. So let me put it uh, based on for deciding the task, and the other input is input for the model. So what are the inputs for the model, right? To actually take the action. So that is one is the observation, right? So what is this? So current screenshot, okay. And so this is one thing which is required, and many other things can be guessed from it. But let's say there you also have the information of uh, for the current task, what is the trajectory, right? So trajectory of actions, right? So trajectory of action. So basically, let's say you were in your Gmail. Now you're coming to, let's say, the a game you want to play. So the trajectory would be closing the Gmail, clicking on the game icon, then clicking on the new game and all those things to getting to, let's say, you're playing Minecraft. So getting to the uh, uh, your world, right? The new world. So there is a series of actions which you took from click to scroll to drag, and all these actions make a trajectory or a chain, right? So that also can be fed into the model to like make a decision for the next task, right? So that is the second thing. The third thing, right? So third thing would be okay. So third thing will be, let's say you the name is the understanding of state, right? Of state or uh, so yeah, understanding of state. So what this is? So okay, so let's say you're playing table tennis, right? Now, if I give you screenshots of someone playing table tennis, uh, how would you know that whether the player who has something a bat like this? Uh, a player who has, let's say, the table tennis bat like this, the ball is here. Is he hitting the ball or he has already hit the ball? So this requires good understanding of the state, which is which has to be given and which cannot be easily informed from one screenshot, right? So this is inferred from one and two again, like the previous thing. So prediction and understanding of state, all these things are inferred from the two things above it. So that is this. So trajectory of actions, trajectory of observations, and understanding of state, which is inferred. So this is the third is the thing where dynamic graphs, I think, would be required, and we will need to like expand this dynamic graph thingy as and how the agent learns, right? So we cannot just train this on a data set of actions, right? So we have to slowly train it, and the actions have to be collected slowly. So uh, wait, let me put this link on my Discord. Just a sec. By the way, this Mango bot for you is an open source project. So if you want to jump in, fork the repository, it is open source. So do join in. And also you can join the Discord if you have new ideas and you want to implement them in this project. So it's your project. So do join in. Um, yes. So let's see. So put it on Discord. Everything good. 9 minutes. Okay. What do you think of this project, by the way? Do tell me in the chat. Uh, how is what is the watching? Still one, right? Okay, that's fine. Is the stream good though? I just had a shower. तो मैंगो बॉट ये है बेसिकली तो आपको अगर देखना है तो इसमें I've also provided the link, right? So this is the link. You can I've given it in the description, so you can do jump in. And yeah, so this is the uh, wait, yeah. So this is the mango thingy. Hmm, who is it? Zoro. Oh, nice. Yeah. So that is good. Now let's start with something. So basically, yeah. So this is the Mango bot, right? And here, what I've written is this is the file which helps the model to localize the state it feels it is in for any task as such. Firstly, we'll try to use GPT for V and check where. Okay. So let's paste the this thing here for now. Okay. So understanding of state, right? So let's try to get that done for today. That would be our goal. And yeah, that would be our goal. And let's see. So the one of the libraries I like is so what are dynamic graphs? Let's see. Dynamic graphs, right? Uh, suggest dynamic graph representation learning. Yeah, this paper would be nice. Uh, There's a lot of literature for this, but there is one library, IG. Hi, viewer. So you can chat freely in the chat if you have any doubt or questions and you wanna suggest something. So yeah, so PyG was a library I came across, which helps you create like graphs, and which is used in like the graph neural networks. So where is the documentation? Yeah, so let's try this out for today and let's see how we can like develop on this. So production by example, yeah. Okay, let's copy this. Okay, so we have that. Um, okay, okay, so let's see. So Python graph. So we don't have Tau geometry. So let's see how to installation. Yeah. So what we are doing today, guys, is trying to create a dynamic graph where like every state would represent like every observation. It's a screenshot would represent a specific state. So let me first do this. Wait. Uh, so if you have like doubts, let me know. Okay, so yeah, so I've written. See, this is the basic idea for how the bot would look like, and so understanding of state, which is should be an input to the main model. So let's say I'm in the home screen right now. Okay, so let's say this is the home screen. Right. Yeah. So this is the home screen, right? So whenever I look at this screen, uh, like something in my mind tells me that this is the home screen, right? So let's say it might be the icons or the background image, or let's say this the bar at the bottom. So this understanding of where I am should be there present inside the model. So GPT-4 Vision actually is very good at it uh, from scratch, but in some complicated environments it won't know. So we want that understanding also. And let's say there's a trajectory of actions which we have taken, right? So I think like from that trajectory of actions also the state can be determined along with the trajectory of observations, right? So a state is not just where we are, but what we are doing. So as I gave the example, when a table tennis player plays a table tennis shot, and a screenshot of that is there, where the ball and bat are present like this. For you to understand like whether the table tennis player has played the shot or is going to play the shot, uh, you cannot tell with just one image, right? So that understanding of where a person is in the exact state is the key, and uh, so that is one of the goals which I am looking to work on right now, and also like this understanding of states is cannot be just limited to like some states, right? So it has to grow like a graph. So that's why I think dynamic graphs have to be made. So okay, so let's just try this out. Uh, okay, my computer is very slow, guys. Tensor from Torch. Issue here. Name tensor from Torch. Where is from Torch import tensor? What? Mm, 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 mm. What is this issue? Let's ask ChatGPT. Mm, 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 mm. Okay, so it's version issue. Mhm, mhm. Let's try this. Oh my God, 198 MB. Nice. Mhm. By the way, is the stream fine, guys? Like the audio might be a bit blurry because my mic is not that good, uh, and also might be a bit laggy. I'm using a laptop. Hey, Aravinda. Hi. How are you? Where are you from? This might be the first time you're joining, right? Have you used PyG before? Anyone? Uh, so basically, what we're trying to build is a another layer to the brain, something like Jarvis. Yeah, but yeah. So a Jarvis which actually understands us. So, oh, nice, nice. What do you do, by the way, Aravinda? Are you in AI too? Like, my laptop is too slow. Let me show you the project till then. So this is the project, uh, MangoEnv. This is basically a reinforcement learning environment which I've created using PyAutoGUI to take action. So if you check this, there is this env.py file where all the actions are described. And you can just pass in a dictionary to the environment telling what is the class of action, what is the coordinates, and let's say the prompt. It will give you the basically the output observation, and it will actually take the action and then on your PC. So this is the basic environment. Oh, nice, nice. Data science experience. Good, good, good. Uh, so like this is the environment. Do check it out. I've provided a link in the description. And yeah, so I'm a mechanical engineer actually. And I got interested into this, so I've jumped the career, switched the careers. Uh, yeah, so this is the n.py file, and like the bot is still under progress. So Like I've tested like few actions which you can see. Oh my God, why aren't this? Where are my videos? We'll have to check. So yeah, is it done? Okay. Do jump in the project, guys. There is a Discord channel also you can hop in, and like if you want, if you have ideas, you can recommend. You can also send pull requests, uh, and you can like test it on your PC, which would be even more fun because like every PC is different, right? Not only the OS, but see, for example, the YouTube icon might be at a different place on my PC, right? So the graph which is being created will be different on my PC than your PC, and that is what we are gonna try. So yeah, okay, this is working, and okay, how do I actually? So okay, yeah. So how do I print this though? Source and target of nodes. So what we have done is we have given an edge index as a torch.tensor, right? So if I, okay, so if I run this here only, and let's say I print the edge index. By the way, this is the Cody complete AI, which is basically same as Copilot, but is like free for now. So if I print this, why isn't it printing? Okay, so let's print X also. Uh, -101. What is this? Okay, simple example of an unweighted and undirected graph with three nodes and four edges, right? Okay, each node contains exactly one feature. So, okay, so this X is basically features, uh, the values inside of the node, I guess. Edge index is edge index. How are they representing this? So 0, 1, 2, 0 is connected to 1, 1 is connected to 0, 1 is connected to 2, and 2 is connected to 1. Okay. So this basically list tells us how they are connected, and what is this? Contiguous. Just you need to define four index tuples to account for both directions of this. Okay, so like uh, 1 2 and 2 1 basically is the tells you the direction also. So let me try to change it and see. So let's print data object. Okay. And what if I do data? This might have been good in Jupyter Notebook actually. Dot, what all do we have? Nodes, data dot node. Okay, let me print this. 0, 2, and 2, 0. Uh, Let me check. So, see, this is the zeroth node, right? This is the first node, and this is the second node. So 0 to, so we want to represent this graph, right? So 0 and 2 are not connected, so they won't be coming in the edge attributes, right? Edge index actually only tells us about how the nodes are connected and the direction of it. So if it is going from 0 to 2, uh, there will be a directed graph, and we will visualize that in something else. We'll try to visualize that also, the direction arrow also. So let's see. Uh, so like how can this be useful? The direction of the graph might be, for example, in a situation where you are jumping from, let's say, you're clicking a button, for example, a link, and you're going from this state to the next state, but you cannot come back. So that is a directed graph, right? So that might be useful there. No, it's not a cyclic graph. It's just this graph. Uh, and like you can like tell me if I'm wrong. I'm just a student also actually. I also not that good in graphs, but I guessed we'll have to learn it for this project. So okay, and yeah, so these are the nodes. Okay, similarly, I think we can do this. Okay, this doesn't have nodes and edges. How do I print it then? Okay, okay. So besides holding a number of node level, edge level or graph level attributes, data provides a number of useful utility functions. Okay, so it has a graph level attribute also. Mm, okay, so data dot keys. Okay. Okay. So data dot num of nodes gives you the nodes. Node types, node features. Data. Okay. Data is this. Okay. 5G contains a large number of data sets also. That's good. Mhm. But we won't be using that. We'll have to create our own. But how do I visualize the graph? Let's see. 5G graph. Uh, okay. Okay. Network X. This is nice. Import network X. I think this can be used. This is nice. Okay, let's try this now. If you want to try out this code, I'll just push it after the stream on MangoBot in this graph localizer, so you can like try it out uh, using an X. So network X is a library, I think. So what does it do? Let's see. Oh, nice. It's working. I have that. G dot add node. The graph G can be grown in several ways. Okay. To get started, look at simple manipulation. You can one node at a time, or add nodes from an iterable container, such as a list. Okay. You can also add nodes along with node attributes if your container yields two tuples of the form. Okay. So color is red. Okay, got it. So what does this do? Check. So how do I print this? G dot node. Oh, see, nice. It's printing the nodes. And let's see what if I do this. Oh, nice. And this also. So it's printing the nodes. What if I print edges? Okay, empty list. That's good. G dot, I need node attributes. What is this? Huh. So node attributes are discussed further below. Nodes from one graph can be incorporated into another. HLS path graph and add node. Okay. One by adding one edge at a time. Okay, so G dot add edge and okay, this is the edge. So if I do this, okay. Nice. So okay, now let's try to create that graph which we had in PyG, this one. So it has three things. So comment this out. Let's copy this. Let's do it 0, 1, 2. It's not visible. Let me zoom it a bit. So 0, 1, 2, G dot add edge. Now is it visible? Yeah. So Z0, 1, 2, G dot. Okay, let's first do this. And then it's from 0 to 1, 1 to 2. Okay. Okay, we can pass in this also. So it is, let's say 0 to 1 to 2 and 2 to 1. Acha, okay. I don't think an X dot graph is can allow you this. Let's try it out though. and we want from 0 to 1, right? Let's print this. Oh, nice. 0, 1, 1, 2. Yeah. So see, nx dot graph, I think there will be something as directed graph also. Yeah, yeah. See, this diagram. That's good. Let's now check it out. Now I think both the yeah. See, now both the things are there. 1, 2, and 2, 1. That's good. Okay. Now how do I visualize this? Okay. Mhm, mhm, mhm. This is all okay. G dot nodes, G dot edges. One can specify to report the adjacent degree from a subset of all nodes using a n bunch. Okay, we can remove it also. But what is this? Is it the attribute? Okay, it's the name. We can also have a string as a name. That's good. So what if I do g dot add, if I pass in monkey. Oh, nice. Okay, got it. So we can have a, let's say, not a monkey, but home screen. Then we can have similarly search bar, or not search bar, Valorant, let's say. And we can have YouTube, and let's say we have Google. And what if I run this? Okay, that's good. That's good. Okay, numbers can also be printed. Okay. So edges are in the form of list of tuples. That is good. Using the graph constructor. Okay. Let's come to the constructing of a graph later. Let's try to visualize it now. Visualize it. Uh, Fast examination of all nodes adjacency pairs is achieved by using g.adjacency. Okay, so edges basically can have weights also. That is also good. That is the key thing which we will need afterwards. So for example, let's say where it can be used is, let's say from a state, there are, let's say, three things which we can do, like three actions. So that weight can tell you the action probability, and more the path which is traveled will have more weight according to some logic. Let's do that later. Graph attributes, yeah, this is good. So today is Friday. This is graph attributes. You want okay. Node attributes. Okay, so we just specify the name of the attribute and some value to it. Got it? Mm, mm, mm. So let's do it like this. So this can be a attribute of the node itself. So rather than having it like this, let's have a let's say type home screen, type Valorant, type YouTube. Oh, this is nice. Google, and just delete this. Uh, Invalid syntax. Why? So G dot add nodes from. This works somehow. Okay, so this, okay, because what if I do type home screen and Well, okay, so for now, let's do it one by one. Let's see. Uh, what if I do? Okay, okay. And what if I do 0, 1, 2? I want this edge. I want this edge. I don't want this. And I want node attributes also to be printed. So G. Okay, that's good. So this we have done properly. Now let's. I'll be back, guys. Once. Hello. So we have got this NXT room on this. Okay. Now let's get to visualization. So what are they doing? What if I do this? What did they draw? Uh, oh, nice. See. So we have finally plotted this thing. So, so see now we can also see the arrow, right? The direction. This is nice. This is wonderful. Now let's move ahead. So let me just push this much. So let's say it is there add. Okay, now what we want is, let's say, yeah. So let's say now we can visualize the graph. That's good. We can add edges, we can add nodes. But now let's say if I how do we do that? Um, we need some kind of a pointer, right? Which tells us where we are. So it's the current node. Let's say def. I need a add node ID, node type, and again add interaction. Let's say. So let's say some action is taken. Node ID, node type, action, right? And node type is basically the state node ID, okay. And let's say for now we only have a okay. Now let's say from 0, 1, 2, right? We want the third node from 2. So and let's say we take some exception from 2. So the edge should also have an attribute, right? So how do I add edge attribute? Um, VFH, yes. Uh, okay. So basically, what we want is this from 2 to 3 and with action equals to, let's say, click. Right. This is what we want to do. Yeah. Uh, so from 2, 3 is made. That is fine. But now we want it through a function, right? So def add interaction from node ID. Uh, wait. So let's do this like this. Previous state. This is previous state. I need a wait. I need a new node first. So I need a new state. Type has to be, what will be the type of it? Previous state action and type. Okay. This is the node add. Then I want c dot add it. Previous state to state action is action. Okay. Now let's do add interaction and G. See, I want it from 2 to 3. It should be click type variant, right? And then I want this part. Ah, wonderful. Let's say I now do it from 2 to 4, double click and let's say notepad. Add interaction 3 to 5, 2 to 5. I need type and I need Valorant B. Let's do this and let's see. Oh, wonderful. See, so now we are even we are getting this like new graph. And let's say from all this interaction, again, we are coming back, right? So from 5 to 1, let's add that also. So let's stop this and right. Okay. 0, and I if type exists, if g dot as add h, else I want both the things. Right. And now, what if I do 5 to 0? Yeah, wonderful. I got a back edge also, back to 0. That's good. And what if I print now? Without notes, tree of 0, let's say. What attribute I get? Oh, wonderful. It has home screen. So it's working, guys. Let's let's do this much for today. I'll add it. Check it out. Thanks for joining in. And see you soon. Bye bye.